Hello friends of data streaming and stream processing. Welcome back to Data Streaming Quick Tips. I'm Gunnar, and in today's episode I would like to tell you how you can use Decodable for rekeying a Kafka topic. So this means taking data from one Kafka topic, changing its key definition, and then writing back the data into another Kafka topic. Alright, let's do this. Before we dive into the details of how to rekey a Kafka topic, let's briefly discuss why we would want to do this in the first place. In order to do so, let's look at an example. Let's assume we have a Kafka topic with records which represent geometric objects. They have properties like shape, with values such as rectangle, circle, square, and so on, or color, with values like orange, purple, green. If we put those items onto a Kafka topic, we might have records like a green diamond, a blue square, a purple circle, and so on. Now, one of the defining features of Kafka is its scalability. This means that the data from one Kafka topic can be spread out across multiple brokers in a Kafka cluster. To see how this works, let's take a look under the hood. Each Kafka topic is organized into partitions, which each take a share of the data. And this is where the notion of the Kafka record key comes into the picture. It defines to which partition a specific record should be sent to. In our example, the object shape is used as the partition key. The Kafka partitioner calculates a hash of the key value, which then determines the partition of the record. All objects with a square or circle shape are sent to partition 0, all triangular or hexagonal objects go to partition 1, and all the diamond objects go to partition 2. Distributing the data across multiple partitions allows you to scale out your load to multiple broker nodes in a cluster. But it also comes with some important semantics for your Kafka consumers. Those are typically organized in groups, with each group member subscribing to a subset of the available partitions. In the example, consumer 1 is subscribed to partition 0 and 1, and consumer 2 is subscribed to partition 2. This means that each consumer will receive the records with the same key in the exact same order as they have been produced. It also means that all records with the same key will be processed by one and the same consumer. But what should we do if we want to make sure that all the orange or all the purple objects are processed by one and the same consumer? As the topic is partitioned by shape, the records with the same color are distributed across all the partitions, and thus no ordering per color is guaranteed. This means we need to rekey our topic. In other words, modify the key for each record and write that data back into another topic, in this case, keyed by color. The question now is how to implement such a rekeying process. For instance, we could implement a bespoke microservice using the Kafka consumer and producer APIs. This wouldn't be too hard to do, but then we would be faced with the operational overhead of running the service. Similarly, we could use stream processing APIs such as Kafka Streams or the Flink Java API for implementing the rekeying logic. But again, we would have to operate such a service or a Flink cluster. So instead, let's take a look at how to rekey a Kafka topic using Decodable fully serverless style. So in order to make things a bit more tangible, I've built a small example application. It's a plain Java application which uses the Kafka producer API for persisting records with purchase orders. And I'm using the order ID as the record key, and then the value is just some random data of order ID, product ID, and so on. So let me run this example, and you see it's going to insert those purchase orders. And I also can take a look into the corresponding Kafka topic. And here I'm using KCAT and JQ. So the output is a bit nicely formatted, and I see now my data, the Kafka record key, the value, and also my partitions and offsets. Now, while the data is keyed by order ID at this point, let's assume we want to make sure that all the purchase orders for one and the same product ID shall be processed by one and the same consumer. For instance, to make sure that there only is a single writer which updates inventory counts. In order to achieve this, we must rekey the Kafka topic. Okay, so let me go to the Decodable web UI and set up an instance of the Kafka source connector for ingesting the data from our purchase orders topic into Decodable. When setting up the connector, I need to specify all the information like the broker URL, the topic name, security details, my credentials for accessing the data within Kafka, and also I'm specifying that I want to ingest the data from this topic from the current offset. The data needs to be sent to what's called a stream in Decodable. So there's a logical stream of data. In this case, I specify this should be my purchase order stream. And also the data on my connection and on the stream has a schema. So this describes how does this data look like. So for each attribute of my purchase order records which are coming in, I need to specify what is their name and what is their data type. So the order ID, that's a big int attribute, and I need to specify the schema for all the attributes of my order records. Lastly, I need to give a name to the connection. So I want to say this is my purchase order source connection. Let me set this up. And now at this point, this connection is in a stopped state. So it's not running yet. And the last thing which I need to do now is I need to actually start this. So let me click the start button for running the connector and deploying it in the data plane. So once the connector is started, then I can actually take a look at its state. And if I take a look at the metrics to the low right, we see more records are coming in. So the record count is going up. And I also can take a look at the data on the stream where this data is sent to. So I can run the stream preview functionality, and then I will see a sampled subset of the data which is ingested by this data from the Kafka connector. So having set up the source connector, now it's time to set up a Kafka sync connector. So this will take the data from this decodable stream, create a new Kafka record key, and then write back this data into another Kafka topic using this new key. And for the fun of it, I'm going to use the decodable command line interface instead of the web UI. And here I have commands like decodable connection list or stream list, which show me, for instance, the set of existing connections or streams. Then I also can set up a new connection. And for that, I'm using the decodable connection for short, create command. And I specify all the relevant information like the schema of this connection, the bootstrap server, my security details, credentials, and so on. And very importantly, I specify that the product ID should be used as the sole key field. So there might also be multiple fields in this Kafka record key. In this case, it's just one, the product ID. So that's very important because this is exactly the core part where we change the Kafka record key. So now we can take a look again at the connections which exist. So now there are two. So there's my source connection and there's my sync connection. I can take a look at my new connection using decodable connection get. So this shows me the status of this connection, all the information. And as before, the connection still is in the stopped state. So I need to run decodable connection activate for actually launching it and deploying it into the data plane. At this point, both of my connections are running, so I can actually take a look at the entire data flow. So I can start at looking at the source connection. From there, I can navigate to my stream, can run again the stream preview to see that new data is coming in. And from there, I can navigate to my sync connection where I see the metrics count is increasing. So the data is flowing from the source topic, is being rekeyed, and then it's being sent to the sync topic. Finally, I can take a look at my data in the output topic. So again, I'm using kcat for this purpose. I'm just adjusting the topic name, and then I can see the data with my product ID as the Kafka record. So you will see the Kafka key there, but also if you take a close look, you will see that all the records with the same product ID, they will go into the same partition exactly as we intended it. And there you have it. We rekeyed our Kafka topic fully serverless style using Decodable and 2 fully managed connectors in about 10 minutes of time. I hope you enjoyed the video. If you did, please give us your thumbs up. Subscribe to the channel if you don't want to miss any future data streaming quick tips. And if you want to play around with this all by yourself, then head over to decodable.co where you can find out all the information about our free tier. Until later, happy streaming!